Hello and welcome. Today we're going to be dealing with right triangle trigonometry. As always, we're going to be going over 5 questions and we're going to explain them and look at the intricacies of this question so that you can ace the SAT math portion of this topic. If you like these videos or find them informative, please be sure to like and subscribe. With that, let's get on to our first question. Here it is. In the figure to the left, two right triangles share a side and the angle A. The measure of A is unknown, but we're asked to the ratio of L to S. Well, the ratio of L to S is simply L over S. So we just want to find L in terms of this, and then give it. Let's see how we're going to do that. Well, since this is A right here, then we know that since this is S, then this side length right here is going to be S over cosine of A. Right, so S over cosine of A is that side length because the cosine of, so if we multiply S over cosine of A by the cosine of A, we get X, which is what this is, right? So adjacent over hypotenuse as cosine should be. So this side length is going to simply be S cosine A. And then this side length is also adjacent to this one. We're going to take that and divide by another cosine of A. You're going to get S over cosine squared A to get to L. So that's what this is. And we end up with 1 over cosine squared of A. So 1 to cosine squared of A, which is answer choice D. Let's move on to our next question. All right, here it is. Question 2. The figure above AB equals 5, BC equals 3, and DE is parallel to CD. Well, immediately when I see that, I start thinking of similarity. But if sine A is 1/2, what is the value of tangent of C? So we're not really talking about similarity here, but it is good if you can pick up on that. But anyway, let's get back to this. Sine A is 1/2, so that over that is 1/2, which means that D point E is 5, 2.5. Now tangent of C, well, actually, let's think about a couple things. 2.5 here. By the Pythagorean theorem, AE is going to be 2.5 root 3. Which means that if we look at this, that we have this 30, 60, 90 triangle, and that AD is going to be, or CD is going to be the half of the hypotenuse. So if we're taking this whole triangle, we have CD is 4, AD is 4 root 3. So tangent of C is 4 root 3 over 4, which is just going to be the square root of 3, which is answer choice C, as we can see there. And we can move on to the next question. Let's get on to it. The figure above, cosine of BAC is going to be 2 over 2, and sine of CAD is going to be 1/2. What is the measure of BAD? Cosine of BAC is 2 over 2, then BAC is going to be 45 degrees. And if this right here, if sine of CAD is 1/2, then CAD is going to be 30 degrees. So total, right, so our answer is then going to be 75 degrees, which we can see here is answer choice C. And we can move on to the next question. All right, next question. Here it is. Triangle PQR above point S lies on PR. The cosine of QPR is 3 over 2. The measure of PQS is 15. What is the value of sine of QSR? Well, let's see what we know. Well, the cosine of QPR is 3 over 2. Then cosine is 3 over 2. And we know that we have this. We can write root 3, write 1, write 2, make a 30, 60, 90 triangle, where this is 30 degrees. Right? And we know that if cosine of QPR is root 3 over 2, so cosine of this is going to be root 3 over 2. this QPR is 30 degrees by the fact that the angle of our triangle have to add up to 180 degrees. PQR is going to be 60 degrees, and since PQS is 15 degrees, that means that SQR is going to be 45 degrees, and QSR is also 45 degrees. The sine of 45 degrees is going to be 1 over the square root of 2, or root 2 over 2. So that's our answer, and we see that this is answer choice B, and we can move on to the next question. Here we are, and here it is. Triangle ABE and ADE are shown in the figure above. AD and BE intersect at point C. Cosine of ABE is 1/2, and tan of ADE is 2 cosine of ABE. What is the measure in degrees of ACE? Well, cosine of ABE is 1/2, so that means that let's draw our right triangle out again. We draw our 30, 60, 90 triangle out again. 1, 2, 3. So this is going to be opposite of 3, so it's going to be 60. So that means that ABE is going to be 60 degrees. And tangent of ADE is 2 cosine of ABE. Well, 2 cosine of ABE is 2 times 1/2, which is 1. Tangent, the tangent of something equals 1, so 2 sides, well, 2 legs are equal. So you're going to end up with a 45, 90 triangle. So this is 45, this is 45, and we're asked for the tangent of AD. We're asked for the measured degrees of AC. So how do we approach this problem? We know that this is a 90-degree angle right here at BAE, so that this is going to be 45 degrees. That this right here is 75 degrees. So BCA is 75 degrees, and ACE is 180 minus 75 degrees, or 105 degrees. That's the measure of ACE. And we're done. All right, so as you can see here, right triangle trigonometry. Remember 3 basic rules of trigonometry, which are TOA. Remember that. That'll take you surprisingly far in trigonometry. Right, where this one sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So TOA, right, that's how we use it, with O is opposite, H is hypotenuse, A is adjacent, and SCT for sine, cosine, and tangent. Remember those 3 rules? You remember the geometry skills you've already acquired through triangles and algebra, and that is it for this topic. I'll see you next.